Okay, so can all of you see my screen?
Okay, so can just wait for 5 minutes. Is that fine?
Okay, fine.
We won't be taking that much time for the example, so we can just do it slowly.
Okay,
You can
then.
just take your time.
While we're waiting, how did you guys find all the sessions so far? This is our last session, by the way. You guys can unmute and tell us, or you can send a message in the chat. Do you guys think we should have covered more, or were they too simple? Were they too easy, or too boring? Very interesting. Please come on, give us your feedback. Indeed. But this has been going on for 3 weeks, I think. It seems like yesterday. Interesting and easy to follow. Nice. All this was really great, interesting. Thank you, Shrishti and Sadeshna. Did you guys learn stuff from the sessions? Did you get anything out of it? Yeah, also, I hope all of you guys are attempting the mini project, because you will learn a lot by doing. All right, nice. Learned in every session. Excellent. Okay, Praneeth and Vidya, let's start. There are 40 people.
Yeah, bro.
It's being recorded anyways.
Okay.
Oh, yeah, the optional we'll send you guys can ask for solutions in the group. If the assignment is closed, we'll help you out with the solutions. Okay. All right then. Let us start with today's session. Okay, so we're doing Fusion 360. Welcome to the last session officially. So what have we covered so far? We've done 2D sketches, 3D models. We made some simple rigid models, the teapot, the paperclip, the bracket, and the simple model, the introductory model. Now all of these are rigid. There is no motion involved. We've done 2D sketches with constraints, the model I took. We have done constructions and stuff. So this is what we've done so far. In today's class, we're going to be seeing how we can add motion to our models. How can we animate them? How can we simulate how they behave in the real world? Fusion offers this concept called joints. What are joints? Joints are part of an assembly that are designed, okay, typo, that are designed to enforce some kind of relative motion between assembly components. So I have two parts, I have two bodies in my Fusion design. I can tell Fusion how to move them relative to each other so that I can simulate how they behave. In the real world, there are multiple kind of joints. You guys have probably studied about joints in the human body. You have ball joints, slider joints, uh, planar joints, hinge joints, etc. In mechanics, the names don't differ that much, but in Fusion, a joint is defined somewhat differently. A joint is just a mathematical relationship between two bodies. So in Fusion, you will tell Fusion how you want one body to move with respect to the other with some mathematical relation. You will specify two coordinate systems on each body, and you will tell Fusion how to move them. So Fusion has quite a few joints to offer: cylindrical, planar, linear, revolute, rigid, ball, and pin slot. This is an example of the ball joint. So you can see this larger sphere can rotate around the smaller sphere. A revolute joint just involves rotatory motion in one on along one axis. So in this revolute joint over here, you can see it rotates about this axis. The ball joint offers you rotatory motion in any axis. All three X, Y, Z axis, you can perform rotation. A planar joint would just have one body move along the other body such that the two planes are always in contact. So the bottom surface of this yellow cylinder will always be in contact with this blue surface. That is a planar joint. You can guess what the other joints are. The linear joint is just you move one body along a straight line with respect to the others, with respect to your second joint. A cylindrical joint combines linear motion and rotationary motion, kind of like a screw. Okay, so that is our theory done. Okay, so now let's look at some examples. For that, I shall take attendance. Also, yeah, guys, I noticed there are not a lot of people in today's session. Yeah, I have stopped screen share. I'm gonna open Fusion right now. But yeah, make sure your friends are here because we will cover a bunch of interesting stuff that will help you in the mini projects. Okay, so all of you should be able to see my screen. You should see these four bodies over here. Can you guys please confirm that?
Yeah.
Okay. Okay, so I have here a few examples of some really basic joints. You don't need to model this in Fusion for now. Just follow along. I'd like to show you how some joints work in Fusion. So I'll just show you around the body, the file. I have a few sketches from which I made all these components. I have four bodies: body one, body two, body three, body four. And now I will show you how to create a few basic joints on them. Now the thing in Fusion is before you create a joint, you first need to you cannot do this on a body. You first need to convert it to a component. What is a component? A component is just a group of bodies on which you can perform some extra functions. So let me do that now. So I'm going to select the first body, right click and select create components from body. And you can see I've gotten a new component, component one. So let me do that for all four bodies. Okay. So now I've created four components. Do you guys have any questions about that? No questions at all?
Yeah, you can go ahead.
Okay. Okay, so now let me start creating joints. You go over into assemble over here and select joint. The short key for that is J. All right, so you see on the right, I have this pane on the right that allows me to select the two components between which I want the joint. And in the motion tab, I can select the type of the joint. Okay, so I'm first going to create a joint between these two bodies over here. Look at how when I hover my mouse over these joints, these different points on the body are highlighted. And you can also see this blue line, green line, and the red line. These blue line, green line, and red line denote the coordinate axis with respect to that body. So for now, I'm going to select the point on the very bottom of the body over here. Okay, so that is my first component that I've selected. Second component I select will be, I'm going to select it over here at the very center. And you can see Fusion automatically arranges it properly. Sometimes this will not be the case. It will be at an awkward angle, in which case you can change the angle, the offset X, Y, Z. You can flip the body over to play around with the relative orientation. But generally, Fusion does a good job of figuring out what you want to do. What I'm going to do is create a revolute joint. Okay, you can see how it behaves. You can see the bottom blades moving with respect to the top. I can set a minimum angle, a maximum angle, the default rest angle, etc. I can specify the axis about which to rotate. Let's try x-axis, and it rotates very weirdly. But notice that Fusion automatically selected the z-axis. Fusion will generally be able to tell how it should be rotating. Let me try a slider joint, a linear joint. You can see it slides along the z-axis. I could also have it slide along some other axis, but again, as is the case, Fusion has chosen the most appropriate um, the most appropriate axis. Once again, I can set the minimum, maximum, and rest. So let me do that right now. Um, Let me try first enable that. I'm going to set the maximum to 20 and the minimum to -20. So let us preview it. Okay, that is very little. I'll make it -50 and 50. Okay, so you can see it goes only from -50 below to +50 above. I have set the motion limits. This is much more reasonable because before it was going through these blades up above. That does not look very real. Let me show you the cylindrical joint. You can see it's behaving like a screw. It will rotate along the x-axis and move along the rotate along the z-axis and move up and down along the z-axis. And once again, I can set uh, motion limits for the joint. So let me disable this. Okay, yeah. So this is the linear motion being shown, and this is the cylinder motion being shown. If I set motion limits, it will try to do both at the same time. Are there any other joints I want to show you guys? Okay, nothing with it. Oh yes, I could also do a rigid joint. A rigid joint just means it will be rigidly attached and there will be no relative motion between the two. So you can see here when I hit preview motion, it just shakes both of them. It doesn't mean it'll actually move that way. It just means that it's just trying to show you that both of them are rigidly attached. Okay. Okay, so what about now? I'll show you with these two bodies. So again, I'm going to hit J for joints. I want to fit this smaller body exactly into this this depression over here. So what I'm going to do is, uh, you notice when I place my mouse on the edge of this second body, it shows me an X to the left. That is the center of the arc, the center from which I drew the arc. If I actually move my mouse over there, it'll disappear. But you'll notice on the left, there is this cross that denotes the center. If I want to select that cross, what I have to do is hit Control, hold Control so that the cross doesn't disappear. So right now I have Control pressed down on my keyboard. I wish I could show you that somehow, but unfortunately I can't. So now I'm able to select that cross. I'm going to select that cross. That is number one. And then I want to select the center of this circle, but at the level of the depression. And to do that, I will place my mouse somewhere at the depression. Again, hold Control and then select the cross that appears. The cross is the center. And you can see it beautifully fits. All right. Let me try making this a revolute joint. You can see it revolves beautifully. Um, I could do a pin slot joint, but that'll just look really awkward on this because this was not designed for that. A pin slot basically is just you move it along two different axes at the same time. So you would rotate along the Z axis and then again slide on the X axis, except that you're not, in a cylindrical joint, you both these axes are the same. In a pin slot, they are different. I could show you a planar joint. Again, it doesn't look very nice because of these walls, but a planar joint just ensures that these two planes are always in contact. So yeah, that is it for some basic joints in Fusion. If you have multiple joints, you can do stuff like set motion links. That means if this joint moves by some amount, try to make another joint also move by some amount. This will come in handy for your assignment today. So yeah, that is all for basic joints. Do you guys have questions? Can you explain
Keshav,
the
Karan
pointer?
wants. uh,
What could you please elaborate? What do you mean pointer?
where do you want the mouse to be placed, and like, how do you want to select it exactly to get the join?
Okay, so these points in the body just tell you how the two bodies are going to be aligned with each other. So if I select this point on body one and I select this point on body two, it just means that these 2 points will be aligned such that they overlap. You saw how the bigger cylinder moved into the smaller cylinder. That was to ensure that the 2 points I selected overlap. So when you're creating a joint, you will tell Fusion how to make it overlap, and then in the motion you will tell it how to move it. So I would select the kind of joint I want. You if you want to select that point, all you have to do is choose this. I'll clear it. It'll show you select. You can just hover your mouse over the body. You will see these points show up. Okay. Two in the second part. Okay. Um. Oh, okay. You wanted me to show you that control thing. Okay. So right now I want to choose the point I want to make the center of this arc overlap with the center of this circle over here. But the problem over here is the center does not lie on the body. So if I take my mouse out of the body, that point will disappear. So what I do is I place my mouse on the body, I wait for that to highlight, and then I hit control. I hold control down. And once when I'm holding control down, that X will not disappear. And I can go and select that X, the center of the arc. Same thing over here. By default, it'll show me the center of the circle on this surface. No, that's not what I want. I want it on this surface below because I want the arc to fit neatly in that gap. So I will just place my mouse on that surface, hit control so that X is still visible. and then go over and select the X. You can see how it neatly fits in. Is that clear? And do you understand that? Okay, any other doubts before we start doing our model for today? Praneeth and Vidya will be doing that. Yeah, don't worry. This was just a demo to show you what you can do in Fusion. Praneeth and Vidya will be building a model right now, and you guys can figure out how to do joints from there. They will actually assemble it with joints towards the end of the class. Okay, so any more doubts before we move on? If you have any doubts about the theory or anything, feel free to ask now, because after this, we're going to be building our own model. Okay, then I will assume no doubts. Praneeth and Vidya, you guys will go now.
Fine.
Yeah.
So hi guys. Now we'll be doing an example for the joints. So we'll be not doing more examples. We'll just stick on to good examples where we can use or learn more joints. So for today's class, we got an example which we'll be dealing with the whole class. So I'll just send you the example in the chat.
Praneeth, I'll do that. You start. We don't have much time.
Screen share. Is my screen shared?
Yeah.
Yeah.
So this is the example which we'll be doing here. So we'll be having 4 parts in this. One is the base, and one is this, the handle. This is the screw, and this is the rod. So I'll be doing the 1 and the 4th part. Vidya will be doing the 2 and 3 and the joints. So this is the base. So once you guys check how it is resembling with this. Aisha, did you send this in the chat? This
Yeah, I'll
whole
send in a minute. I'm sending it.
Okay. So this is the diagram. So this is just the base. This. So guys, once look at this and just think what to do, how to do it. Let's start it in a minute. Guys, can you understand this diagram? Is everyone fine with the diagram? So this is the side view. This is the front back view. This is the top and this is the bottom view. Fine, right? I'll just start. So this is the base here. So this is the base and this is the top part. So how you guys think we should start with the base itself? So first this base I'll start and next this I'll do. So I'll be dividing it into 2 parts. So to start with the base, what I think is so this is the base here. And to start with the base, I'll do this base in the top plane. So in this plane, I'll be doing the base. So that if we make this in this plane, we can just extrude it up. So we'll just make it as rectangular. We'll just make this as a rectangular and we'll extrude it. So now this base is done. What about the top part? How we'll do it? Anyone have any methods to say? You can just unmute and say the method. So now the base is done. Any inputs for the top part? Guys? Okay. No inputs, I'll just see. So I'll start with the base. Now we have the sketch here. So now this is the base. This is the top view. This is the bottom view. From the top view or bottom view, you can see the width, length, breadth of the rectangle. So From here, the length is 170 and the breadth is 60. And just start with the rectangle here. 170 is the length, 60 is the breadth. So we have got a rectangle here. I'll just finish my sketch and I'll just extrude it till where. So from the side view, you can just check this is 20 mm is the length. So we need to extrude it 20 mm. So as I told you, it's better to use symmetry, as you always try to do it in an origin or a plane to keep the sketch in a plane. So I'll just extrude it symmetric, or you can say we can extrude it bottom anyway, is fine. It's 20. So we're done with the base. Next, with the side part, with the top part, how we can do it. So as you can see, we'll just make the top part in a side plane. So we'll just make it in side plane and we'll just extrude it two sides. Then it's done. So that's the way to do the top parts. I'll just show you, make it. You won't be understanding it now. So at the start, so this is the point of the base. So this is the base here. So from here, we'll be starting at this point. This point will go this way, this, and will come this way. So this is hollow part. So this is the input part and this part is hollow. So we'll just follow this path to make the top part. So from starting from here, what is the distance from the corner? You can just check from here. See, from here it is 35 mm. So I'll just need to go here. If your point is not focusing, just zoom in so that your pointer can be pointed onto any point in the axis. So if you zoom out, you can't point it anyway. So if you zoom in, accuracy will be more. So I'll point here. I'll just need to go 35 distance. And next, we're done with the 35. We'll start with this point. So where is this point? Next, we have till here. Next here we have a curve here and this lines. So till here, what is the distance? It is 60. So we'll just go on till 60. We're done with 60. So now we're done with the lines. So we have this line also. So this is the 60 line and the curve here and the line. I hope you all understood the diagram. So we have drawn the 60 till here and we have this line and this is hollow part. So where is this line? So this is also till 60. Then we have a curve or a circle of radius 20 and 10. But where is the center? The center is till this line. So this is the circumference of the circle. This is the center. So the distance between this center and the line is what? The radius of the circle. So by this we can say this line is the tangent of the circles, both circles. For the radius 20 circle, this line is the tangent. For the 10 radius circle, this line is the tangent. So by drawing the lines, then we can just draw the circle by just using the tangents. So with this, I'll just offset this line. I'll select this line. I'll click offset. So I need to just type the distance. What is the distance between these two lines? It is 10 mm. Just click 10. I want to keep it the negative side. So I'll have to write minus. So minus 10 is done. And just click 10. So these are the both lines I've got. So next I've gotten two curves. Two circles here. Just need to go to circle, enter circle. I've got two circles. Each radius is 10 and 20, means the diameter is 20. And I need to check these lines are tangent with this line. So it's the tangent. Next circle, which has the same center, has the radius 40. Now it's done. So anybody has any doubts still here?
Pranit, what is the thickness of that base?
Thickness of the,
Of the base you just made?
it's just 20. From here you
Okay.
can just, it's fine. So it's 20.
Oh, yeah, actually, Pranit, can you send this? Because the one I sent seems to be outdated.
Okay, listen this. plane. You keep thickness as 40, you can just edit it afterwards. As you can see, this and this are both different sketches. So if you complete this, you can edit it later, right? This can be edited later, and this is different stuff, as these both are different planes. Okay, we'll just get onto this plane. So till this circle and stuff, are there any doubts? Any doubts, guys? So let's continue. So next part. Now we're done with the circles. This center is done. Till here it's done. So after this, till here, we need to draw these two lines. Okay. So what's the total distance till here? Till here to here, it is 35. But we know this is the circle. This is the center and this is the end point. So this will be the radius, as you can see from the picture. So this is 20 and total is 35. So from here to here, it is 15, right?
Pranit, can you explain how you drew that circle again? Pragyan has asked.
Okay, just this. Okay, Pragyan, did you understand till here? These two lines, how we draw on the two lines? Yes, once can ask him. Did you understand?
Yeah, he understood that part.
Okay, now, as you can see, 1 minute. These two lines are perfect here. And we'll having these two curves. Okay, which are the circles, and this is the center point. As you can see, the distance between this and this is 10, and the radius is also 10. So by this we can say the circle here is tangent of this line. The circle, you just need to identify circle here from the center point. As you can see, this comes like this. By that we can say this is the tangent and this is the tangent, right? Did you understand the tangent? How we got the tangent there? Guys, can you reply? Yes, okay, fine with the tangent. So by the tangent, if you understand the tangent, you can easily draw it. So you just need to go to circle. As you can see, the center is on the same line, any line here. Or else I'll just show you with the different, just draw any part. Draw a circle and the same horizontal line of radius 20. I mean diameter 20. Just need to click tangent here. You need to click the circle. Okay. So now it's tangent. Same with the other circle also. Center, click 40. Done. Now both are, now we got the curve here. Right? Did you understand that? Is it fine, Pragyan? Yeah, fine. Okay, I'll just move on. As you can see, we are done till here. The curve is done till here. And we have this remaining part. As I told you, till here it is 20, total is 35 here. And the remaining is 15. So we can draw from here to here 15 from the circles. 15. Make sure these both are tangents. And 15 from here. 15. Now if we are done with this line, right? We can just remove the extra part. So we got the line here. See, we got the curve here. As you can see, this curve is done till here. Now we are remaining with this.
Could you hide the dimensions in your
Okay. Sorry. So we are done with this curve. Is everyone fine with the curve? Any doubts with the curve and circles and stuff? As it's fine. Okay, I'll just continue. We're done till here. So now we'll need to go till here. So what is the distance there? As you can see, the base is 20. Okay. Till here it is 60. So
Pranit,
total is 80. Yeah.
can you explain the curve again?
Okay, I'll just. So did you understand the tangents and stuff? How we got the two circles at the tangents? Yes. Okay. So then it's too easy, right? As you can see, we have this circle of the center of this tangent and another circle of this tangent. We already know the center point and the radius, and we have to just see it as a tangent, that's it. So as you can see, I drawn a circle anyway in the center point itself. In the picture I just showed.
Sunny bro. Hello.
Yeah.
That measurement that has written, uh, that overlapping it's very confusing, bro. I could not see the measurement only.
In the picture you're asking.
No, in the fusion you are building now.
Yeah. What didn't you understand?
You are building that circle and the measurement you have given there and written in the fusion, they are overlapping and it's very confusing to see and that.
Okay, just removed my dimensions
Pranit
here.
will hide the dimension.
I've been hiding it. So as you can see, these two lines are drawn here. So these two lines are drawn here. And this curve, we can say this is the tangent to this line. So that's why I drawn a circle with radius 10 here on the same line. As you can see, we'll be having it in the same line, right? I've drawn it anyway. We all know that this circle is tangent to this line, right? I just need to go to tangent and press the circle and this line. We're done with the curve. And we also know now we are fixed with the center, right? And we have other curve, which is circle with radius 20. We just need to select, go to circle, need to select the center. As you already know the center, just need to click the diameter. So as you can see, I'll just close the diameter. You can just see it. We're done with the circle, right? Are you guys having doubt? Fine. So with the dimensions, you're getting problem. You'll get used to it. It's not a big problem. So next, this line. We are done with the curve. You have to go till here. So as you know, I told you total is 35 and this is 20. So the remaining is 15. This is 15, this is 15. So just need to go till here, draw 15. Draw 15. Okay. I'll just crop the unwanted parts. Okay. Now we are done with the curve. So as you can see, we are done with this curve. Remaining is there. So what I'll be doing? We need to find this height. So what is this height? As you can see, if combined from other pictures, this height is 20. From here you can see this is 20, right? So this is 20. Till here it is 20 plus 60, it is 80. So till here, which is the radius of the circle, right? Which is also 20. So 20 plus 60 plus 20. Till here you got is 20. So we need this 60 plus, which is 20, 20, 40, 100 and 18. 118. So total is 175. So if we remove 118 minus 175, we'll get this height. So which is 57, right? I just need to start here. 57. Done. Next is this. What is this? This also with combined pictures, I have to get this height, this length. As you can see from the bottom pictures till here, it is 35. Fine. Till here it is 35. Plus this, it is 35. So till here it is 70. 35 plus 35, 70. And the remaining is height we want. Until here we want. And another is 40. So 70 plus 40 is 110. So 170 minus 110 is the height length which we need. So this length is what, 60. So guys, any doubts in dimensioning the heights and lengths? Have any doubt?
You are finding the dimensions, right?
It is just seeing, it's you have to get used to that. I think it's complicated, but you can just have to interpret everything. So for the first, this vertical height, I have to check all the heights here in this and this. So in this, you don't have any. So you have a information that total height is 175. Okay. And this will be having different height. So we need to combine everything at once. So till base, we have 20. You have understood from this picture. So till here it's 20. So till here it is 60, right? So 60 plus 20, 80. From here to here, this vertical line, it is 80 plus 20. As you can see, it is the radius of the circle, right? So from base to here, this line is what? 100. So you don't know from here to here. This height you don't know. Remaining is 18. So remain total is 118. So 118 plus this height is 175. So what is the remaining height? So this height is 57. Fine. Fine with the vertical
Okay.
height. Karan, I can't hear you. Your voice is not fine. Okay, fine.
Okay,
With
okay.
the horizontal height, as you can see from the base, you have to check here and here. So total is 170 you get from this picture. So 35 you got it, 40 you got it. And you also know from here to here, it is 35. So till here, from this end to here, 35 plus 35, 70. You don't know from here to here. 70 plus your wanted height, wanted length plus 40. So total is 170. So what is the remaining height? 60. So that is how you got this horizontal length as 60. Fine, yes. I think it's fine. And the other height is 72, as you can see from the diagram itself. 72. And this height, you got this point. And what's the remaining point? Just need to, you got till here. Just need to line this. As you already got this vertical line, this is the line which you already know. Just need drawing vertical line. Okay, just need to draw from here to here. Okay, you already know this line. The distance between them is 8. Okay, so you just need to click this line and go to offset and offset it by 8. Right? And you just need to join these two lines. And the intersecting line will be your part. And you just need to crop the unwanted stuff. Done. So now your sketch is done. So guys, any doubts in the sketch? You can just ask me any. I can explain you. Guys, any doubts? Please react, guys. If not also. Okay. Now we are done with the sketch. You just need to exclude it. How we exclude it? As I already told you, we have made it in a side plane. We just need to exclude it symmetrically on both sides. In the picture, you already got an idea. As you can see, we have got a sketch from the center. You need to exclude it two sides. So what's the length? As you can see, the total length is 40 of the upper side part. So how you exclude it? You just need to select this part. No need of this. As this is hollow here, you just need to select this part. You just need to right click, exclude it, go to symmetric, and total length is 40. So if you use symmetric, you just need to type the half length, which is 20. So now we are done with the top part. So so it's fine, right? Anyone have any doubt with the sketching or exclusion? Any doubts? Any doubts, guys? Small. So we are done with this base. So as
When
you can
with
see this,
fillets, Fillets are there.
What?
Fillets are there for that model.
Yeah, I'll just put those. We just have a hollow here. This is the hollow rectangle you have, and this is the circle. As you can see, this circle is there, and this hollow is there. So where you have the circle is here, and where you have the hollow, till here it's starting. From here, it is also there in the bottom also, as you can see in this direction. This is the bottom part, as you can see, which is hollow. I'll just show you. So this is the hollow part, and this is hollow also till here. Till some distance, it is hollow in inside. It is hollow in the bottom also. So what I'll be doing is we just need to make an cut exclusion, right? Where I'll do this cut, I'll just make a sketch of the rectangle here. I'll just extrude it up and also I'll extrude it down. So we'll simultaneously making both the cuts. So I think you've got an idea how to make the rectangular exclusion inside. I'll just show you how you'll be doing that. Just need to make a sketch in this way. So as you can see, you're getting the obstacle of the base here. You can't just see the correct rectangle here. To see that, just need to click slice here. As you can see, it got slice from the middle. So by clicking slice, you can just avoid many obstacles. So that's how you use slice here. So I'll be making the rectangle here. So what's the dimension of the rectangle? So it is at a distance, it's in the center of this. From here to here, it is in the center. But the total length is 60. So from here to here, it is 30, right? From the third, so 30 will be having the rectangle. So what are the dimensions? So from this diagram, you can see the rectangle dimensions. Once clearly observe, this is the rectangle. I hope you are seeing the rectangle. So the length is 40. What about the breadth? You don't have any breadth here. So total length is 60. This is 20 and this is unknown and remaining is 20 from by symmetry. 20 plus unknown plus 20 equals to 40 plus unknown, which is total equals to 60. So the unknown is how much? 20. Right? So the length is 40 and the breadth is 20. Guys, are you fine with the length and breadth or any other sketch? Okay, I'll just repeat the slice.
Can you show me by just doing?
Which one? Hello?
Oh, all clear, bro. All clear.
I'll just show you the slice option. Okay, this is, I want to draw a sketch here. So I'll be using the sketch. I'll go to sketch. I'll select this plane or this face. So if I select this plane, I'm getting this base as an obstacle. So I can't access the selected plane, right? So what I'll do, from in the right, you'll be having options called slice. I think you can see it from here. Slice, so that it cut the base from the XY plane. Now you can just see the plane you just want. So as you see, I've got the dimensions of the rectangle as 40, 20. So what is the distance from? So from this point to this point, total distance is 60. So at middle point, which is at the distance from this point, 30 will be having a rectangle of dimensions 20 length and 40 breadth. So from here, this is center, right? We'll just let's sketch slice. So we just need to select the distance. Okay, 30. Okay, we're done with 30 distance. Go to rectangle. 40 is the length and 20 is the diameter. We are done with the base. Okay, and done with the sketch. Guys, any doubts with the sketch? Length and breadth, is it fine? Should I explain it again? Yes. Guys. Okay,
Friend,
it is fine.
Karan has asked you to do the 30 line segment again. The 30
Which one?
line.
Okay, I'll just show it again. As you can see from picture, circle rectangle is at center from this. So the total length is 60, right? So we just need to put 30 from this side and keep a center at here. So we don't have any lines in the sketch, right? So I'm just pointing a line here. Or else you can point it from here also. Select this and you have to go till 30. Place it. So that's how you got the 30 mm line. Is it fine? You can just see the sketch and fine. Okay, fine. With 30 and you have to make a rectangle here. So the length are 40 and 20 as I told you. The length is 40 and the breadth is 20. Okay. Now we can slice it. So select this plane, finish the sketch. Select this plane or the sketch, extrude it. So I'll be not using one side as I have to extrude it inside and also in the bottom. We don't even use symmetric also. As you can see, we need to equally cut both sides, but we have to extrude it where I'll just show you with the sketch. So till here you can see the hollow part with the dashed lines. So from bottom total is 72. From this sketch you can see the upper part is 10. So the whole length from the dashed lines to the base is what? 70 minus 10, which is 62. So the length we have to extrude up is 62. And till here we have to extrude till where it gets hollow. So the both distance are varying. So what we'll use? We use two sides. So one distance is what? 62, as you can see from the diagram. And the other distance till where you can get the hollow part of the bottom. So we are done with both the extrusion. Just click X. So we are done with the extrusion. Now what we have? I mean, so we need to use, we also have a circle here in the top part. We are done with the base. We have a circle here. So as you can see, we'll be needing the circle. So for the circle, I just need to click here and the dimensions are what? 30 and 20. As you can see from the picture, what is the radius of the circle? 20. And the inner circle is, outer circle is 30 and the inner circle is 20, which is also at a distance of center, right? So I just need to click office. The total length is 30. I just need to click 30, 30, right? And put the circles. 30 and other one is 20. Extrude it up. As you can see, we got a length which is 18 from this direction. And inside part, you can just make a cut itself. Extrude it and cut it inside. And just see the hollow part here. So now we are done with the first part. Are anyone having any doubts here? Any doubts, guys? Okay, I'll just move on to the second part. So we're done with the base. So this thing is the second part. This is the rectangle stuff you are getting here. Is this sketch. I'll just share it in the this is the second object we're doing, second body. Surface. We'll just select the side plane. You can just do it in any plane or extrude it in any plane and just do it in the side plane. Okay. Next, this is the rectangle. So as you can see, this is the rectangle of 60 and 34.5 lengths. So I'll just make a rectangle here. And this part you can see this is the triangle here. As you can see, we can make a rectangle and just we can cut this out. I'll just show you. First, make a rectangle here. So this is the problem with Fusion. It most of the time it won't select the point. So you have to just be used of it. As you guys can see, it's not selecting any point. Sometimes it's the problem. Let's do the sketch again. Let's select the side plane. Go to rectangle. So the length is 60 and 34.5. Done. So this is the rectangle and we have to remove this triangle here. So what we can see, we have to specify these points and these points. Okay. What I'll do is I'll just select this line and I'll click offset and offset it by -15 so that I'll get this line, the distance, so that I can join these 2 points. I'll just show you this to see. So I have to also get this point. What is the distance this point? This and this. So the total is 27.5 and the remaining is 34.5 minus 27.5, which is 7. So this is 3.5, this is 3.5. So from this point, we'll be having 3.5, 3.5. And from once to this point, we'll be having 3.5. So we just need to join this point, this point, this point, and this point. So this part we have to exclude. So what is the length? As you can see from the side part, this is 18 mm. So I'll just select this point, this and this, and I'll just exclude it. Both sides, so total is 18. So symmetrically, I have to write distance of 9. We are done with this. Guys, any doubts? I think mine is fine. I have to screen share. Guys, it is still lagging or once can you check case of hello? As you can see from the image, we'll be so now we are done with the rectangle and stuff. So what you can see from this dotted lines, as you can see from the front part, so this is the back part and this is the front part. So from the front part, what you can see, we'll be having a circle of diameter 12. Okay, so this is the circle from the side part. As you can see, this is the circle and this is the circle. This is the same circle you'll be having seen in the side part. And what is this dotted lines? This you can see from the side part as a diameter of 8 circle. So this is also 8 circle. So first we just need to make this circle. Let me show you guys. So this is in which plane? The front plane. So this plane. Just need to click sketch and go to this plane. I need to draw a circle of radius of what? 12 diameter. Sorry, circle. 12. Okay. Till where you have to exclude. So it's in the base. So what is this length? So till here it is 15. So what is this distance? As you can see, this distance from this center is, so till this center you'll be having 7. So from here to this center 7. And this we don't know, and remaining is 15. So what is this unknown? So till this center it is 7. So till this 7 and till here, what is this radius? So this is 4. 7 plus 4, 11. So till here it is 7 and this is 4 and this is 15. So 7 plus 4 plus 15. Right? 26. Guys, any doubts with the dimensioning of the circle? Guys, any doubts with the circle dimensioning of the distance? Guys, react if you, or else please ask if you have any doubts.
Yeah, go ahead, Puneet.
Okay. So this is the 12 circle. As you can see from the image, how much we are different. So till here it is 7, as you can see from the top part. And what is this? This circle radius, which is 7 plus 4, 11. Till here you got 11. And till here, how much? 15. So which is 26. So we need to exclude this part. How much? 26 distance. So select the circle. Right click, exclude. How much? Minus 26. Okay, now we have done with one circle. We have another circle, as you can see from the side plane. So it is at a distance of 7 from this end and its radius is 8. So I need to select any top plane and its distance any line. So as you can see, it is a distance of 7. The circle is 8, radius is 8, sorry, diameter is 8. So we just how much we excluded. So as you can see, the whole circle is throughout the rectangle. So we just need to exclude it on whole where it gets cut. So it's done. So these are the two parts which are done. Any doubts in these two parts at any point? Guys, any doubts? If it's done, Vidya will continue with the other parts and the joint stuff. I think it's fine. Vidya will just save it. You just continue with it.
Praneeth, Karen has asked it out.
First circle, I'll just show you. So this is the 12 circle, right? 12 diameter circle. As you can see from this picture. So this point, if you align to this line, this is the center of this circle, right? So first, this is the big circle. This is the small circle, right? So till here to here, you can find this distance as 7 mm. So till here to here, you don't know. You can see from this distance, the center, this is the center to this line, and this is the line. Center to this line is what the radius of the small circle. So till here it is 7. Till here it is the radius of circle. So 7 plus 4, which is 11. So till here it is 11, till here it is 15. So 11 plus 15, how much? 26. Fine, Karan? If you want, I can just explain it again. Okay, fine. Okay, now with I'll continue. I'll just, if you have any doubts, please ask at any point of time.
Yeah. So
I'll just explain it again. As you can see, this is the line. So this is the line. This is the side part. So till the small center circle. So this line is the small center circle. So till here it is 7. Till here. So this is the hollow part of the length. So this length we have to exclude. Got it right? So we know this distance, which is 15. We need to find this remaining distance. As you can see, this till here, this is the hollow circle of the small circle. This is the center part of the small circle. So from center to this line, it is 7. So from this line to center, it is 7. So from center to the remaining distance is the radius of the small circle. So this is the center, this is the line. So till center it is 7, till the another line, it is what? The radius of the small circle. So 7 plus 4 is 11. So 11 plus 15 is 26. So total we have to exclude it 26. Got it? Kumar, did you find? Okay. Vidya, you continue.
yeah, so Pranit is basically done with the base and the jaw. I'll be teaching you how to do the screw, the handle, and the joints part. Pranit, can you share the projections of those both in the
Fine.
chat once again? I want you people to have like a decent look at it once. Pranit, Karan seems to have some doubt.
No, it is not clear. It is 6 or 8. So it is 8 about the circle distance.
Yeah, so I'll get started.
Karan, and fine. It is not clear. So it is 8, not 6.
Okay. So I'll start. What I want to do is I want to put them as separate components right from the beginning. So just go to the top part, right click it, and you'll get an option called new component. Okay, just click on it, and you guys will be getting this job box. Here you can name what your next component would be. I'm just making the screw right now, so let's name it as the screw. Okay. And if you wanna activate like the component, you must go for the circle you see right here. Like I go to this one and I click this circle, you can see the components present here. So I just click this. I go to create sketch now. I select this name. Now, so what I'm gonna do right now is draw a rough sketch of the plane view of the screw, and then I'm going to dimension it and revolve it finally. So let's get started. I'm going to draw a rough sketch of the plane view of the screw. Okay, this is just a rough sketch of the screw, how it is going to look like. I'm going to the dimensions now. I want you guys to like clearly hover over this and you'll find this white dot over here. Click it and then again click it. So the radius is 6. I'm going for a radius 6. And again click it over here and click it over here. This is supposed to be 5, so I'm just putting 5. Again, I'm just making sure I don't want you guys to click on this line. I want you to click on the white dots and then go for the dimensions. This length is supposed to be 10 and this length is supposed to be, excuse me,
Now go on stream with you.
yeah, this is supposed to be 6 and the next one is supposed to be 4. So I'll just do that. And the height between these two, it is supposed to be 4. And between these two, it's again 6. Coming to the next part, the length of this, it is supposed to be 96. And the height here, it is supposed to be 10. This part is supposed to be 25. And then this is supposed to be 12.5. So we basically done. I'll just finish the sketch. I'll go to create. I'll put revolve. This is the profile. I'll select this axis. So you guys can see the screw part is done. So just click OK. And for the handle to be installed in, you guys, like, we need a hole in it. So I'll just go to create sketch again. I'll select the same plane. I'll go to this part here and I'm going to create a circle. And the diameter is 11 and it is at a distance of 13 from this edge. I'm going to finish the sketch, continue, and now I'm going to just extrude this part on both sides. And yeah, we are done with the hole as well. I know that I went really fast. In case you guys have any doubt regarding this, you can just ask. I'll teach you all over again. Any doubts, people?
Can you please show the sketch?
Sketch, the 2D part, yes. Yeah, this part.
Yeah. How you are taking the measurements, ma'am?
The measurements I've already put it like. Do you want me to show how I take the dimensions, or you
No,
want me to tell you how I calculate it?
it's already given, or we need to find out.
No, it's already given in the 2D projections that Sunny just shared.
And we've sent
Okay.
the drawings in the channel, so you can go through that. Vidya, can you repeat
Let's
how
see.
Anika is asking you to repeat the part from after sketching?
Yeah, so this is like the basic sketching that we've done. Then I'll go to create, I'll put revolve. I'm going to select the sketch part of the profile. And for the axis, I'm going to go with this lower one. This is getting highlighted, you can see it. I'll go for this one, and your 3D part will be done with this. And again, we want a hole here for the handle to fit in. So what I'll do is I'll again go to create sketch. Again, I'll choose the same plane and I'll place a circle here with a diameter of 11. I'll finish the sketch and I'll just extrude it outwards on both sides. Yeah,
Fine. And you can continue.
yeah. So I'll create another component. This is our handle. I'll go for create sketch. Then, um, and again draw like a rough sketch of how our handle is gonna look like, and I'll again dimension it and then revolve it. So this is just a rough sketch. Now I'm gonna dimension it. This part is going to be 6, and this part is 8, and this part is 156. This part is again 8. This part is 6. The distance between these two, it's 5. And yeah, you're done. I'm done with the basic 2D sketch of the handle. I'll just again do finish sketch, revolve it. This is the profile, and this lower part for the highlighted one, you can see this line will be our axis. And we're done this. Guys, are you fine till here? If you have any doubts, I'll just repeat the process again.
Did you also show them some of the fillets? Adam base.
And it what?
Okay, I can leave it. Some fillets so that it's curved.
Which one are you talking about? Is it about the screw or the handle?
The main part which I have done. I forgot to
Um,
do the fillet, so
okay,
okay,
it's
no
fine,
problem.
it's
You can
fine.
continue.
Yeah. So, guys, are you all clear till here? Because now I'll be moving on to joints. Okay, fine. Now I'll be moving on with joints. So, what we're gonna do first is make this handle get inside this screw. So, I'm going to go to assemble, join. For the first part, I'm going to select this one and the second. Now, I want you guys to have a careful look here. Hover your mouse around here until you find like the inside cylindrical part. Once you find it, like it must be this way, as you can see. Just press on it and you can adjust the handle however you want it to. Go to motion, select rigid in case you want to just review your motion. Yeah, it's done. It's fine. It's perfectly fine. So just click OK. Our first part is done now. Now, what we want to do next is attach this part to the jaw. So once again, I'm going to go to assemble, join. This is the first part. Again, guys, have a careful look. It's not this face, but it's this one, the front face of the screw, as you can see. Select it and go for the next one. It must be the inner cylinder, as you can see, to the components. In case this happens, I just want you guys to flip it, move it inside a bit. Yeah, this looks perfectly fine. So again, you want the motion to be rigid here. So select rigid here and then it's done. So this okay. I'll just check if any of them is grounded.
Yeah, I think
Guys, in
screws.
case if,
Ah,
excuse me,
no, nothing. Go on.
yeah, just make sure people, if any of your components is grounded, you need to right click on the component and then unground from parent. You must be doing that unless you cannot actually move it. Okay? It is going to be over constrained and you're not going to get your desired joint. We are now done with this part as well and coming to the last part. You just want this one to get inside here and you want be able to slide this one up and down. I'm going to assemble again, join. The first part is again this face that you can see, and the second part is the cylinder inside here. I'm going to look at it upside down. Yeah. I want this to be a slider one. Slider basically just moves it up and down, and it's already set to Z axis, so there's no problem. Once you're fine with it, press OK. I see. Okay, this is not the this is only the component. Keshav or Sunny, can you guys just look at it?
Vidya, I think base is not a component. That is why the issues happen. Go to bodies and convert it.
Okay, okay.
Like right click, you can
Yeah. So I need this a component. I'll go to assemble again. Mm, Select the first phase and go again, select the second one, flip it over. Okay. Yeah, it's done.
Vidya try animating the joint so they can see the full. That is nice to watch.
Yeah. Keshav, can you just do that? I'll just save this part.
So okay.
Yeah.
Yeah. Before I show that, you guys have any doubts in how we built it? Anything at all? Guys, anything at all? Because that is the model for today. Can you guys see my screen?
Keshav, no. Can you try sharing it again?
Okay, now visible.
No,
Not
Mm,
visible.
yeah. Yeah, it is visible.
Okay. So you guys can actually see the joints over here. So the symbol is the rigid joint. Oh. I can animate the joint by right clicking on the joint and hitting animate joint. So it'll animate that joint alone. What I want to do is animate the full thing. You can see it only animates one at a time. For that, I'm going to have to ground the base. Which is that. So right click on that component and ground to parent. Um, Hopefully this works. Okay. So now I want to, you can see there are two joints over here. I've selected the slider joint. It has an arrow. You guys can see it has an arrow between two lines. That is a symbol for a slider joint. Let me right click on animate joint relationships. So you can see the whole thing will go up and down. This is not how, ideally, this is not how it would work. You have to set the motion limits for it to go down and not up. But yeah, this you get the idea about how it works.
Keshav, just show them the old model,
Okay.
last model.
not the unedited one.
Which one? That's one
Yeah,
joins one, which you just click. Yeah, that's fine.
startup hanging. Awesome. You guys can see running Teams and Fusion is not healthy for your laptop at the same time.
And it's too big
Okay,
software.
there we go.
It's
Yeah.
lagging.
Okay, so you can see it. This is the model we had made while designing these sessions. Yeah, so you can see the motion limits are set over here, so it goes completely in and goes only up to the base. So yeah, this is how you're supposed to set motion limits. Yeah, do you guys have any doubts about today's session? Okay, if not, then I'll show you guys the assignment. Or with your friend, you want to do that?
Continue. No.
Okay.
Mm.
So very broadly put, this is your assignment for today. You guys can see this photo I have up here. Guys,
Yeah, we can.
okay. So you see there's a wheel. There's a piston kind of device over here. So you can tell just looking at the photo when this wheel rotates, this shaft over here will pull this block left and right. So we are converting rotatory motion into linear oscillatory motion. That is your assignment for this session. You need to create a model in Fusion that showcases this mechanism. The design is completely up to you. Use your creativity, make it as complicated as you want. We don't mind, but just ensure that these joints, these basic joints are implemented. So in your model, when a wheel rotates, we should see something moving linearly, oscillating linearly. Okay. You guys have questions about the assignment? No, there are no measurements or anything. This is completely up to your creativity. Make it as big as you want or as small as you want. So before you start, sit down with a piece of paper, sketch out a rough diagram of what you will do, what you're going to make, write the dimensions, and then start designing. That'll be very helpful. Okay, so do all of you understand the assignment? Previous assignment is not what added. Sorry. Okay. Let's wind up the session. But before you guys leave, how many of you guys know what we do in Sahaay?
What do you understand by the name of Sahaay? What do you think? And
Do you
by
guys
the
know what
name,
Sahaay means?
and note that we don't do any
Uh,
social service. Like donation stuff. So please note that point.
Okay. Um, let's offer a reward for this, guys. Vidya, Pranit, what do you want to offer? First one to guess what Sahaay means.
We'll just post your name in our Insta.
Insta, no, Asmita won't let us.
We'll just put a
Okay,
story.
we'll post, we'll mention you in the InnovateX, the official channel.
Or maybe 2 or 3 bonus points in that assignment.
Yeah. Helping, um, that is, that is,
We
that
don't
is,
need the
okay.
meaning of
Yeah, that is
Sahaay.
correct.
Yeah,
Karan
but
is so close.
we don't need the meaning of Sahaay. We need meaning of
Yeah,
what we
yeah,
do.
guide would be more appropriate. Yeah. Yeah, so basically we are the club of social innovators. We we are engineers, we are very enthusiastic about tech and stuff. And we decide to use that to try to solve some pressing social issues of today. So I'll show you guys a photo of our brochure. You guys have the links to our social media pages?
Yeah.
Okay, send that in the group as well. So yeah, this is our brochure for this tenure. You want to contact us, you can contact us at this email, teamsahaay@gmail.com. These are the projects we're working on this year. There's an LOTR reference in this brochure. If you guys can find it, again, same reward. You guys can see the brochure, right? Okay. Like Pranit and Vidya, you guys also try to find it. So far, nobody has found it till now. There's an LOTR reference
Which,
somewhere in the brochure.
yeah,
I'm a big LOTR, by the way.
LOTR,
Lord of the Rings.
Lord of the Rings.
Yeah.
What you want to include with that, bro?
No, there is a reference to Lord of the Rings in the brochure that I'm sharing right now. See if you can find it. Come on, guys. Some of you must have watched the movie or read the book. Yeah, you can see some of our achievements over here on the left. LinkedIn and Instagram QR codes are over here. You guys can scan it and follow. We will be posting updates regularly about the projects that we work on, the competitions we enter and stuff. There's a description of each project over here. We're working on 4 right now. Pranit and um, Vidya are working on the agriculture umbrella. Under the agriculture umbrella, we have Agriscape and Shell Splitter. Pavesh, you'd remember him from electronics, Karthik from software, and Aryaman from software. The 4 of us are working in the assistive technology region, Gesterize and Pathpal. Yeah, okay, Shashi, good job. The projects may seem daunting. That is a reference to LOTR. The actual line is even the smallest person can change the course of the future. Challenges may seem daunting, but within each one lies the potential for greatness. Okay, so Shrishti goes into our WhatsApp channel, and who was the other one? Um,
Karan.
Pragyan. Okay, Karan also. Okay, Karan, what we guys were teaching during the session is pretty much what we use. Granted, this is the basics. In college, we actually in our club we actually get the materials and physically work with it. So in electronics, we sort of studied about ESP32s and Arduinos. We use more advanced version. We use computers on a single board. In Mech, we are teaching you Fusion. This is completely designed. You guys can actually message Praneeth and Srividya if you have more questions about the Mech module. But there is a workshop in IIT Madras where you can actually go build the stuff you design. Software, we do a lot of machine learning with libraries like TensorFlow, PyTorch, Keras, MediaPipe, etc. Please do follow our social media handles. We will be posting updates. And you guys can add on as well.
I think I've covered most of them. So by the name, we are Sahaay. Don't take us wrong, we are not any donation or anything. We're just a tech innovation club. So feel free to promote our club anywhere, and please do attend the workshops and stuff if you can. So that's all. So
What do you guys
guys,
think of the
is there a
series?
question? You have any ideas for the social innovation? Any social ideas? If you have any ideas, you can just message us or anything. Yeah, Kesha, you are trying to say something.
How did you guys find the lectures so far? This is our last session,
And
in case it hasn't struck yet.
Guys, which module do you think was the best one? Software, electronics, or the mech?
I think they enjoyed the software a
Oh,
lot.
this is going to create controversy. Watch.
Christy. Yeah,
Software, electronics. Oh yeah, Shishi, this was a lot of fun for us teaching you guys as well. Our first time doing it. So thank you for that.
yeah, you are our first students.
Software. Lakshmi, both as in which two? Software and electronics. Still waiting for a Mac reply. Come on, guys, one Mac. The Mac module was not fun. Hey, friend. Okay, one Mac from the students.
Okay, no problem. Anyway, anyhow, it's a high only at the last. So we are fine with anyone make or let.
Sleepers, okay.
Bro,
All right then,
no
guys.
matter how much
Do
software or LX stuff you know, unless you don't have a physical working prototype, you're not gonna make it. And mech is what is gonna make it.
Oh yeah, that is true. Mech is the only module that is involved in all projects. All four, all of the four that we just showed you. We would not get anywhere without being able to use CAD and stuff.
You can just text us through WhatsApp. We'll be having our numbers, right?
Feel free to give us feedback in the Innovate Text group, WhatsApp, the WhatsApp group as well. For reference, the three of us are project members and coordinators in the current tenure. Asmita and Satyapriya, you guys probably remember them from the very first session. They are the heads of the club. Okay, we'll give you the certificate once we finish grading the assignments and compiling attendance. Thank you guys. Okay, yeah, by the way, the session is over. You guys can leave. If you want to stay back and talk about something, sure, go ahead. We are also jobless right now.
Yeah, please talk anything you want. You have been muted whole class.
One thing I'd like to add, you people are really, really so beautifully consistent. Like, I really like your consistency, guys.
Yeah, I didn't think we'll be getting 60 people in the last class.
60 is quite good. In fact, I think we started out with around 110. So that is
Yeah,
like
yeah.
more than 50%. The current Asmita is slightly busy today. She's in a meeting, so unfortunately she can't join. We'll ask her to send a message in the group. Close the series. Thank you everyone for attending. It was a lot of fun.
Guys.
I have a question. How many of you guys are joining IIT Madras or in IIT Madras already?
I was
If so,
about
you
to
guys
ask
must have
that.
heard about us. If so, you guys must have heard about Sahaay.
Okay, Shant, which branch you are?
One.
I'm electrical. I am from electrical engineering.
You
Electrical
okay.
engineering. Electrical.
Okay, studying BTech now or you're coming to BTech?
Second year, sir.
Okay, second year. Where you're studying your BTech?
IIT Madras.
Okay, okay, sorry.
You're going to second year.
Sir.
Are you going to your second year or going or you
Second sem
completed
completed.
second year?
Coming to third
Oh,
sem.
okay. Okay.
Thank you.
Yeah, okay, thank you. Okay, IIT TAB indoor. VIT. VIT AP.
AP, Amaravati.
Okay. Alright, guys. Thank you very much. Vidya, Prani, if you guys want to say something before.
Dude, I feel emotional over this.
You guys are from South. Yeah, from Keshav's name you can say. And I'm from Hyderabad. And Vidya is from Vijayawada. So, yeah.
All of us are at IIT Madras, by the way.
What summer school? So, anyone is coming to IIT Madras this year as a freshie?
Out of the 42 people remaining, I don't think.
Yeah. The person who is coming might be too busy.
Huh. I mean, actually, they have 1 month remaining now, so.
So, they are in which round problem?
Huh?
Which round is happening? Is the JOSA completed or they're in which
I'm
phase?
not sure. I think round 4 is over. So, yeah, people are still applying.
Yeah.
Yeah, by the way, we are just talking about random stuff. Feel free to unmute and join. Like I said, we're jobless right now.
Thank you, guys.
Kasai.
And TSS. So, probably are BPC student. Is that Karan? Yeah. Feel like family.
Your family.
Oh,
You're being too emotional. I didn't think you'd be that much. If you want, you can put good night, good morning message to us all.
Oh,
Yeah, we are
It's
open to
fine.
them as well.
Yeah, we'll be happy to reply you all.
okay, for Arduino and Raspberry Pi, Arduino has great documentation. For Raspberry Pi, there is this nice YouTube channel. I do not remember the name, but you can send either anyone from Elec module or you can send me a message. I'll give you the YouTube series. All right. You can also ask Bhavesh and Niveda. They are the Elec. They are the ones who took Elec, so they will also have a lot of resources.
Okay, guys, any doubts? So 40 people are there still. Nice.
I feel like I must point out the irony over here. I am actually an Elec project member in Sahaay, and I've been taking the backend software sessions in this summer school.
So that's why you're called in Keshav. Handling
I don't
both
know, but
software and
the point
mechanical.
is, we expect you guys to study interdisciplinarily, do stuff from all domains.
Yeah, that's the power of IIT. You can do anything. Probably IITM.
But yeah, Sahaay is like a wonderful platform. Each and every one of it. It does have knowledge in that electronics and software and like domains as well.
In the software.
Hello.
If there are any juniors joining ATM, do check out the club. We will be recruiting soon. Also, yeah,
Hello.
make sure you guys don't neglect the mini project that is necessary for the certificate. You will learn a lot while you're doing it. The 4 problem statements that we released.
Uh, I have a
The
doubt.
WhatsApp group, okay.
Uh, I have a laptop, but I don't think the laptop I'm using is very much compatible with Fusion 360. It crashes all the time. The laptop is getting so hot, and it turned off yesterday when I was trying in my room.
You have a do you have a college issued email address?
No, he's having
Yeah,
problem
I
with
have
his
a college
laptop.
issue email. Yeah, I have my
No,
college
so okay,
email address.
try applying for Fusion education license, and then you can use the
Okay.
online version of Fusion with that account. I've sent a link for this in the group. If
Okay.
not, you'll probably just have to borrow a laptop.
Because I have to practice the stuff as well
Yeah.
because it took a long time to catch up with you people because there is a certain delay with my college Wi-Fi and all, and the system is crashing all the time during the sessions. I have to listen to
Okay.
the online lectures and all. It took a lot of time.
All right. Yeah, none of us are running. Yeah, even you guys would see my laptop hanging. Fusion and Teams don't go well together. Fusion itself is pretty heavy.
Yeah, like my laptop is 7 years old, and I don't think it can
Oh,
handle much.
okay.
That's the issue. And all you guys know all this stuff, like what was being
As
taught
in,
to us.
huh.
Yeah,
Every
you
one of
can
you knows.
message us and
Pranit
then
and
call.
Vidya actually do this full time. They are mech members in Sahaay.
Okay.
Yeah, you
To be
can
honest,
call
can I tell
us.
you something about our college? Uh,
You guys go
in
Pranit,
VIT,
Vidya.
in VIT we do have PCS clinics, but we people don't even know how to write a code for Arduino or Raspberry Pi. We don't even know how to do the connections and all. People just get the code from GitHub or somewhere else and they do the connections from Google and they get the marks. So none of us are like innovative people like you people. You people really taught me something and it's been grateful for being here and learning new things. I guess I'm going to do the things by understanding next time. So thankful for you guys. That's what I would like to say. Thank you for this
Thank you.
session.
Thank you. Yeah, we also enjoyed it a lot. Thank you very much.
Yeah, thanks a lot. We really appreciate you guys telling these things. We actually feel a lot better when we listen to these. In case you guys want to know in specific about any more of these stuff, you can DM us. We'll show you some YouTube channels, and we can also suggest you some courses on some online platforms like Udemy, which are really helpful for us.
Yeah, is there anything to say, guys?
Oh, yeah, if there's nothing else, we'll end.
Yeah.
Oh, yeah, Shastra workshops, you have to
It's,
come physically to campus and attend.
it is a technical fest of IIT Madras.
You guys should actually have heard about it. I think it's like the second biggest in Asia or something. Or is that Sarang?
Shastra, not sir.
Okay, Shastra.
We'll be having two fest. Shastra will be learning, Sarang will be enjoying. So
In IITM, we have this fascination with Sanskrit words. All our events, teams, and all are named after Sanskrit words.
and
Shastra
we'll
is
be
quite literally sciences. Sarang, I'm not even sure what that means.
yeah, in the first week we'll be having both first 1 2 weeks. First week we'll be having Shastra, second week we'll be having Sarang.
You guys can make it to Shastra. You won't regret it at all. It's like really, really amazing fest. You guys get to watch Robo Wars. If you have a decent team, you can even get to participate in it as well.
Yeah, there are many competitions to participate and earn prize money and certificates.
There were competitions, debates, seminars, workshops. It's just fully packed. To me personally, Robo Wars is the best part.
You want to explain it?
It's in the name Robo Wars.
Yeah,
I think
statement.
most of them
It,
heard of
it,
it.
it, it is self-explanatory.
So guys, any doubts about IIT Madras? Anything you want to know? For clubs, we have clubs for many things and many com teams also. So every com team has a name starting with letter A. I hope you heard many com teams from IIT Madras.
Raftar.
Yeah, Raftar, Abhyuday, what's called Agnirat. Then I heard many com teams there.
So yes, if you don't have anything else to talk about, we'll end the session. No, Akshat, if you have problems with attendance, DM one of us, will help you out with it.
Okay, guys, thank you for everything. Bye.
All right, we'll end the session. Thank you all.
Thank you. Thank you.